Hello everyone, I'm Manahil and I will present my 201 project, measuring the speed of sound in air using various methods with the help of videos and pictures. Smartphones have become a significant part of our lives, and they contain applications and sensors that have made conducting research cheap and easy. Therefore, we use them to measure the speed of sound and carried out error analysis to check the validity of our experiments. We carried out 3 experiments. The first is the time of flight measurement, and we made use of an app called Firefox, which uses a microphone to listen for sound and an acoustic stopwatch that is triggered by a loud sound. So basically what we did is we used 2 people standing across from each other who clapped alternatively to trigger and stop a stopwatch. I will show in this video how we carried this out. And this caused the stopwatch to stop. So we used this equation and we used the distance twice because of how the sound traveled back and forth. And we used the change in time to find the speed of sound. We also took into account the time delays in both of the stopwatches, which accounts for the change in time A and change in time B. You can see from the table that the mean value we obtained for the speed of sound was 352, and this is across varying distances. We changed the distances for like a lot of measurements, and we found that the speed of sound we obtain is quite close to the theoretical speed of sound. So we would say that this experiment was successful. Our second experiment was performed by sweeping frequencies from 300 to 3000 Hertz in 3000 seconds through a frequency generator app on our phones. We made use of a 50 centimeter long plastic tube, open at one end, and placed the frequency generator directly on top of it. A spectrometer app on one of my friend's iPad then started to record the maximum amplitude against the frequency. And you can see the method in this video. So this is the spectrometer app, and the phone placed on top is the frequency generator. We generated varying frequencies, which showed resonance peaks on this app that uses Far's Fourier transform as its algorithm. And then we took these resonance frequencies and we plotted them against the odd harmonic integers. And what we found from the slope was A, which was 213 Hertz, and we put it into this equation on the left to find out the speed of sound, which came out as 340 meters per second, which is also not a bad value. In our third experiment, we made use of the same plastic tube and submerged one end into a bucket of water. The frequency generator app was again put on top of the other end, and fixed frequencies were generated. This time, we changed the length of the tube, and every time a loud sound was heard, this end was marked and checked with the spectrogram, which showed us the peak at where this loud sound was appearing. So you can look at this video to get a better idea of what I'm talking about. This is us generating the fixed frequency, which you can see on the spectrogram app. And then we changed the length until we got the loud sound again, which we checked again on the app. So we recorded the distance between 2 consecutive loud sounds, which corresponds to 2 consecutive nodes. We know that the distance between 2 consecutive nodes is lambda over 2, and we use this to find the wavelength. You can see we used AB, BC, CD, and we almost got the same values for each, which means that it is consistent. we knew the frequency, so we used the formula speed is equal to wavelength into frequency to find the speed of sound. And you can see that we got a range of values, and this could be because of there was some background noise in almost all of our experiments, which led to some error. And there was also, in the last experiment, there was also a human error because of us, one of us was putting the meter rule, and the other was sometimes would tilt the tube, which was because of human error, we got these errors. So, but we still managed to carry out a project that gave us a relatively accurate value of the speed of sound using just phones. And thank you.